factorial.
Well, factorial is
Not for every programming language. That would just be certain. That's not a standard. Yeah, that's not a standard programming thing. But we could say that. But more often, we would use it as a not operator, like in an if statement or something would be the more common use. So that one for sure could get thrown in some other category. Okay, Zoom session's going. Have you got it?
Yeah.
I'm not going to click next until you're ready. Making you play without your Zoom session. It's like driving blind. Assignment statement. Very nice. Now, let's look at those other two before we go on. Why are those wrong? When we're doing programming, the answer has to be on the left of the equal sign, right? So here, we've got the problem on the left of the equal sign. So even if 4 were a really bad variable name, it still is not correct because it would have to be flipped around. Does that make sense to everybody? Because that's a really, really common beginning error or error that beginning programmers make is they'll put that variable that they want the result of their equation in on the wrong side of the equal sign. And we always have to start with variable to receive value equal whatever our equation or whatever we want to set it equal to is. So make sure that we always have our answer kind of on the left. So remember, it doesn't follow those math rules that we can have things on either side of the equal sign. It is not that way. We have to have the result first, if that makes sense. We solve a lot of problems in programming. Okay, pseudocode. Very good. It's just like code. Now remember, we're following conventions from our textbook, but it is not strictly formatted. These are just guidelines that our textbook has given us about pseudocode. So if we didn't follow those rules, it would still be pseudocode. Concatenation. So all the big words in here. All right, good job. Prompt. Good, good, good. Integer. I guess you're so quiet this morning. Ready for that video, huh? There's only one integer up there and everybody's just slamming it. I can hear that. One person wasn't looking at the Zoom. Got the wrong one. What is this one? The result. Really good. Remember what that means. It's going to do integer division and give us the remainder. And then what about this one? You're huge. I can do it all. Yay. All right. Before we start looking at other stuff, oh, we need to see who won. Sorry. April, yay. Who's first here? I saw it bumping around. I said, yay, good job. Everybody, hey, you guys are great. Good job. And I was just looking at some different things for getting us prepared for our exam. Now, remember, we have some confusion about that because our unit exam is supposed to be Thursday. But since we can't have class Thursday, since our classroom isn't available, you're going to take that at home on your own. I'm going to bring up Canvas here. Like we were in an online class, which means that you will adhere to the strictest of rules and only use the notes that you've created with your study group as a resource for the exam. When you look at your module section in Canvas, which I know you should have already been looking at, your Unit 1 exam, there's the practice exam and the Unit 1 exam. The due date is Friday, so I set the exam to be available from Thursday morning until Friday night at midnight. So I didn't want to just give you during the time that we would have had class, but you're welcome to take it, you know, during this time, since this is the time in your schedule allocated for our class, and just get it out of your way. But if you don't, you know, if you want to wait until Friday, you can. So it'll be open throughout those time frames. Now the other component, there are, you guys won't see this one, let me remove it. Confusing you. The other thing that we have is the hands-on exam component, and this is due February 11th. And I'm gonna just change that unless everybody's already turned it in. You have not. And I want this to be due Friday night also. So I apologize for the date and changing it on you at a late notice. I thought that it was already set that way. I missed that. So with all of our changes going on, we fix it right now. So if anybody's already turned it in, I'll give you some extra credit. Yep, we have people that have, so we'll give them some extra credit points for being so on top of things. And then that should say Friday evening now. The change to our schedule I mentioned is just because of the snow days last week. So the Skills USA contest that they were supposed to hold last week got canceled. And when they looked at the schedule this week, they said, well, Thursday, this classroom would only have to cancel one class in the morning to have the contest. So that's what they're going to do. So let me know if I've got you all messed up, and I'll make it up to you somehow. Uh-huh.
So you mentioned nothing about submitting Pseudocode.
For this?
Yeah.
There, no pseudocode is required. Just your Raptor flowchart file.
Just an input-output, so.
Do I?
So it just seems very simple. So.
Uh-huh. Yeah, it should be simple.
Okay.
Hopefully it is. And sometimes, I hate to say that, because when you open Raptor at home or someplace else, it might not seem easy right then, because it's one of those things that when we're working together, it's like, oh, I have to do this, you know. And when you're on your own, if it's not, don't worry about it. Just, you know, kind of step back and think about it a little bit. Give your brain a second to contemplate what's going on and go back to it. But we'll try to get done today with some time so that you could do that here in class on the classroom computers, so that you don't have to install Raptor at home. But our schedule is making that a little bit more difficult than I had hoped. So let's look at some of the beautiful pseudocode and flowchart examples we had last week from our 2 problems. Let me see what we've got here. Looking at the supermarket, does anybody want to show us what they did, or do you want me to just pick some? I can pick some. Mhm. Just pick some. It's okay.
Show off the solution that I wasn't allowed to submit, but
Oh, that would be bad.
I don't mind going.
You want to show? Go for it. Let me just, I'll stop my share and you can grab it. Let's see what you got. Move this over here so everybody can see it. Let's stay with our supermarket first.
Oh,
I don't want to go to the bowling average yet. He's bringing up that hard one.
here on the left is pseudocode there. Doing my declarations here for variables. And I write out the prompts precisely, so when I go to the router, I can just copy and paste.
Great.
Here is the calculation, and then the output. I wrote it away so that it concatenated everything together. So simple, single line speak.
It looks very nice.
Variables being declared here is their initial types, and then the inputs are all in the input module here. Calculations done here, and then the output there, and we can run it. It says here that the price per ounce for the bread, the price that I put it in there is just over 12 cents per ounce. The total price for 1 pound and 12 ounces of bread is $3.48. And they're coordinating everything.
Great. Looks awesome. I have a question on the pseudocode. We don't have specific rules or anything for it. One thing, though, that's nice for us to get in the habit of doing, I'm just going to bring up the textbook here and let's look at it. I want to see. I know we have pseudocode all over this chapter, but of course I won't be able to find it if I'm looking for it. Right here, whenever we are doing our pseudocode, it's nice if we label the beginning of our modules or our subprograms. So with our supermarket, it's really small and it's totally obvious to see where those different modules are. I mean, when we look at it, it's got really nice comments and stuff that show us where they are. So it's not like something that we wouldn't be able to see. But as that pseudocode potentially grows, if it were to get bigger and bigger and bigger, then it might be hard for us to identify the beginning and the end of a specific module. So it's kind of to lead us into actual coding practice too. It's a good idea if we say, you know, start module and then the module name and then end module at the end, and we indent all of that pseudocode in between the two. Would you mind trying that with your beautiful pseudocode? So we can show everybody. And your variable declarations at this point are going to be in our main, so perfect. Tab. Good question. Important. Press tab. Because sometimes you just don't. No.
Sorry,
No, you're fine. You're great.
about it.
Yeah. Okay, so let's go ahead and put the end main there. And then let's label the beginning of your input before or after your comment, because like I said, the comments are really nice. And if we just tab and indent, Python is going to make us code that way. It's going to force us to indent our code in a structured way. So it's just a nice, good thing for us to get used to. Exactly, appreciate you doing this for us to really illustrate to everybody. Now, just like in our Raptor flowchart, in our main, we have to call our input module and our calc module and our output module. Let's put those calls in our pseudocode too, and then that way we'll know our pseudocode that we want to call those other modules. Okay, everybody, does that make sense too when you're looking at it? It seems like a little bit of overhead, but as we go, like I said, and we're developing applications that get bigger and bigger, it'll help us to know where things begin and end. We always want to kind of identify the beginning and the ending of any sort of job or activity we're going to do, and that helps us with that with our pseudocode. Now, the pseudocode, that's that Raptor flowchart. That's great. Yeah. Give Zach a hand. Thank you so much, sir. Yeah, we're going to, after our unit exam next week, we're going to take that application and write that program in Python. So we'll be able to take it to the next step. So we'll see our design tools leading us into our Python code. Does anybody else have a solution to that one that they want to share? I promise I won't criticize. I think they're all awesome. I just want to kind of guide everybody to doing things the way that we can all understand and benefit from the most. Okay, let's look at our bowling scores then. Now the bowling scores application Isaiah is even kidding about. I want to let him do it the way he wanted. And a lot of people asked, I need score 0 or score 1, 2, 3, and 4, 5, 6. And I have those extra variables for the bowling scores. And I said, no, can't have them. And that's one of the only times in our class I'll say that to you. Normally I'm not me how you use variables. But for this bowling scores problem, that's a really important part of the problem solving. How can you solve this problem using only these 3 variables? So I'm going to pick on somebody. Josh, will you show everybody yours? And Josh was going to be gone, so he had sent me his earlier, and I just think that he had a really good solution. So let's see if we can take a look at it. That's okay.
So in my code, I remember what I did. I did this years ago. I made each module or each person their own module, and then I made local variables inside there. So I used like score 1, 2, 3 here. And then I went to Shannon's module and I did score 1, 2, 3 here, and then team average module, and since that's mapped to the output. Of the averages and the team average. Here's my pseudocode for it. My main module, declaring everything right there, and then calling my, I was like, if you're calling my modules, why not? Call them all. And, yeah.
So then you went ahead and calculated the sum for that person, that bowler, within their input module, right?
Yeah, so I asked my score, asked for all three of the scores, and this one, score 1, 2, and 3, and set to the sum of that. And it goes on to the next module, which is the next module. And does the same thing, and just throwing them back up to the main module.
So we had to take that math out of basically our process module, right? And move it into our input module to be able to capture that information and only use those 3 variables. So it was just kind of a limit that we wouldn't normally have in real life, but just kind of a problem solving thing for us to really think about. So thank you, sir. Anybody else? I know we had a lot of other solutions.
I'd like to share mine.
Sure,
I
let's see
handled
it.
that one differently than you did.
Yeah, I think that's good too. That's the coolest thing about programming. Except it's kind of hard when you're starting.
All right.
Okay. Yeah, it was one of those backups.
So I just declared the 6 variables. Score 1, 2, and 3, Shannon's average, Jasmine's average, and team average. And apparently my Raptor is not showing what I had, so I'm going to pull and see it displayed. But in Shannon's module, I just set score 1 as Shannon's first score within that module and set the average for Shannon off of that. When it moved into Jasmine's score module, I erased whatever was in scores 1, 2, and 3 and replaced it with Jasmine's values, creating the average there. And then in the output module, we did everything. Shannon's average was this, Jasmine's average was this, and the team average was set based off of the input from Shannon and Jasmine.
So not too different, huh? Pretty much. Pretty close. Pretty close. Does it look the same? Different too? Good solutions. Anybody else? Something completely different? Somebody that violated the rules and used score 3, 4, 5, which that's okay.
I didn't use score 3, 4, 5.
What'd you do? Let's see. You can tell I haven't graded these yet.
Game like A1, and then I did like game B1.
Uh-huh.
And
Let's
then-
see it.
And then separates out
Okay, show us. That sounds like an interesting solution.
so up here I declared
Oh, neat. Uh-huh.
them all just as different individual variables, and so that way they can be stored without having to really mess with a whole lot.
Mm-hmm.
And it runs.
Bless you.
There's a lot here,
Uh-huh.
but it calls everything. It gives separates it out by like your first score for your average bowler, second score for your teammate. Does that. So it runs, no errors. The only thing I didn't do is I didn't put Jasmine or Shannon.
It's like my scores. Very nice. And as we get into start looking at arrays and things, the way you've done this one is going to lend itself to kind of converting that over. So that'll be kind of a nice example. So it is hard in our class as beginning programmers. Sometimes our book tries to make things so simple that it can actually make it harder for us to just solve the problem because they place so many limits on us. It's like, oh, you don't know about this yet. You don't know about this yet. So I just want you to live within this tiny little bubble and solve the problem that way. And that's very hard to do. So with the limits of the variables that they gave us, I could say that's the only time that I think that it's important, because we are trying to think of ways that we can reuse code and reuse things. Do what?
So you don't care about the restriction the book gives to only 3 modules?
Oh yeah, he'll lose a couple points. I do care about that restriction on that one, yeah. So, and usually I'll tell you, I mean, for most of our applications, you're gonna have pretty specific instructions if it wants something pretty specific. You would have something, so think about it as you begin developing. If you get instructions that say, the prompt should say this, versus instructions that say, prompt the user for this information. That second set of instructions is giving you the right to decide how you want that prompt to be written. The first one is not. It's saying this exactly should be the prompt. It's already been decided. And sometimes we work in those kind of environments where those design decisions have already been made, and we have to make sure that we follow that design or follow those rules. Most of our applications, though, will try to give you that creative flexibility because I want you to have a chance to try different things. So I think it's a really, really good solution. I'm going to share my screen again. Sometimes losing points doesn't mean it wasn't good. Just a couple. All right. I think that's really good. Does anybody else have one that they want to share before I run off looking at other stuff? You guys are just doing such a great job. I'd like to split up into some teams, and as you can tell, it's giant Post-it note time of the semester around here, and I feel like we should jump in that because we've got our unit exam next time, so we'll do some review. So we're going to split up into groups, and I'm thinking that we probably want about 3 people in each group. And here's what we're going to do. After we split up, and I'm going to be adding to this to make it more fun for you, we're going to try drawing some different flow charts and doing a couple of problems to get prepared for our exam. And I'm going to ask you to write the answers on the giant Post-it notes so that then we can all just turn and look at what the different groups have done. So the first things that I'm going to be asking you about are evil math problems. So we might take one of these questions and pose it to the group and have every group answer it on their giant Post-it note so that we can go around the room and review how everybody did and how everybody answered that question. So we'll do a couple of math problems that way, review from our short answers. And then we're going to look at a couple of flowchart problems. The first one, I'm going to ask you and your group to find the sum of 2 numbers. So you're going to just be giving us the logic for this. In this solution, you don't need to have any modules or subprograms. We just want the simple 1, 2, 3 steps to prompt for 2 numbers and add them together and display the answer. So we're going to have simple pseudocode for that offline, not on our big sheets of paper, but then our large sheet, we're going to draw a flow chart that represents that problem. We haven't done a lot of flow charts, so give us some practice. And then the second one is going to be this kind of interesting fruit problem. There are 4 types of fruits. Each student can pick up 2 fruits. There are some conditions which have to be used to pick up the fruits. Draw a flow chart which can take the name of the first fruit as an input and print the names of second fruit or fruits that can be picked up. So like if you pick up an apple, you can only have a banana. That's a rule. If you pick an orange, you can only pick grapes. If you pick grapes, you can only pick banana. So our flow chart, again, will be on the large Post-it note so that we can go around the room and look at each other's solution to this problem. If you want to create pseudocode for this first, that's fine too. It's up to you and your group as to how you do that. So let's see, how should we split up? Yes, sir?
Does that also mean the inverse, as in if you pick banana, you can also have either apple or grape, and if you pick grape, you can have either banana or orange?
I would assume that our first table is not going to have bananas on it. Let's just make that assumption. We're going to walk them through, and our first table's only going to have those three.
So
Because we don't want it to take forever. Huh?
Picking banana first isn't an option, and it wouldn't result in anything.
Right. Since we can't get an orange or an apple off that second table, our second table is very limited. We don't have many choices at all. Okay, so I'm trying to think about splitting you guys up into groups. 7, 11, 15, 22. I think that's going to work. Okay, I want everybody to line up out here, and I think I want, trying to think of what all these, oh, okay, I know. I want everybody up here to be the people that were born like January, and work your way back. So our December 1st are going to be back in the back. So you'll have to kind of talk to each other and decide where you need to be in this line. Then we're going to split you up. I have to use the calculator because my brain is dead. Okay, we're gonna have one group with 4. Let's see how we get this to work out. I thought you were pretty solid on January there. We're getting a clump here. Any other January people?
February. How about March? Okay, I'll let you two come up here. What about April?
He's a leader.
When are you? You're March. You're okay. You're April?
Okay, single file. Get in line. Let's go.
May. Okay, March. I got mine, guys up. Who was March? You're all three March. How about you talk amongst yourself and figure out what day you can be, so you can line up.
Okay, single file here so we can count off like PE or something. You two guys get in the line. Grab those two. Wait, you're not in the line. Okay, I can't count you if you're not in the line. Okay, so we have like, I'm gonna do 1, 2, 3, 4, 5, 6, 7. So remember which number you are, because you're gonna partner with the other people that end up with the same number as you. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 4. You're 4. You got it? 4. Yeah, 4. 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1. Is he 1 or you 1? You guys decide. Okay.
Does everyone know?
Yeah. Let's go back to your seats, and then we'll allocate specific areas for each group so that you can be back at your stuff before we move around. We'll get you guys going here. Okay, as we move, then the first thing that I'm going to want you to work on is this short answer number 28. So I'm going to leave it up here on the screen, and you can work however you want to solve this problem. And we need to see it on the big sheet. So send one person up from your group to get one of the giant Post-it notes. And we have plenty. So if you need more for other things, that's fine. Post-it note and a marker. So So group 1, let's put you over here in this corner if that's okay. And group 2, let's put you over in this corner, kind of wedged here. And group 3, I want you back there by that window. Try to keep everybody out of the way a little bit. You wanna here, take a marker? Okay. For 2s. So we got 1s, 2s, 3s. Group 4, we're going to go kind of that back area. Well, mark. In group 5, you guys. And group 6. You guys take this area over here by our area. And go ahead and be working on that math problem if you can.
So, write this condition or write
Your process and the solution. So you can do it in Pseudocode, or you could just example it to show them what the steps are. So that somebody else who doesn't understand the steps of the problem will be able to understand. Pseudocode, if you were trying to explain it to somebody, the pseudocode would be the steps.
And humans would do it, not how a computer would
How it should be solved, because the humans are the ones that need to understand. Here's this, so he's gonna go over here, so I can hear where you are. Okay, so everybody got enough room? Are you good? Now, we want it to where everybody in our class can solve this problem to answer it on a test. So that's how we want to approach this. How can we explain to someone how to solve this math problem? This is a great idea to come take a picture of it if you want to.
So I guess the first step would be substitute all the x's for 3's, and the second step would be substitute all the y's for 4's.
Yeah. And obviously the order of operation becomes more.
Right. We talked about doing it correctly. If it's just A, there's no order of operation. So what order of operation? But the other one can just kind of be like.
We have to rewrite that so that it processes in a proper order of operation. It's literally going to go left to right as it's wrote if we were to just type it in.
Correct.
So we've got to square the y, then multiply, then divide by 12.
Yeah. And that makes sense, but I mean, are we supposed to write this as a program?
Yeah, yeah, we're supposed to write this as in our pseudocode or actually step through as a example.
Okay.
So
I wasn't understanding. So,
No,
yes.
you would multiply.
So we want to put in to replace the number.
I believe. Then you have to. Well, then you don't have to modify it, just say
So that's how it's written properly, and then
This would be how it's written properly
substitute.
algebraically. So we have to make the program do the math properly.
Pseudocode here. So I guess what I'm getting at is, are we supposed to create variables then for each step?
I would, what I would do is I would be making variables per step. I would, if I were doing this, I would be setting a variable for both x and y, because those could change.
Yeah.
depending on what's
Oh,
going
yeah.
on.
We could just call the variables.
Right.
Yeah.
I would set a variable for
That
the,
portion.
the square.
Yeah. So maybe like step one, just call the variable step one. And just
Yeah.
have that portion.
And then the way we would write it would be, once we know what we're doing, it would be x
16 is the
times
4 squares.
step one, which would be y times y, divided by 12.
Yeah. Okay. Yeah.
And that would allow it to do step one, because we would call for step one first, and then
Yeah, that makes sense. Does that make sense?
I want everybody
Add
to
any
buy
conflicts?
What?
That sound right?
Yes.
Like, yeah.
Do you have to make
There are people in this class that do not understand.
the reason we need to make this a separate step is for this to be written the way it is. This has to be processed first. Otherwise, what will happen is it will multiply 3 by 4 and then square 12.
But could you put the parentheses around the y raised?
Okay.
And then, or put the x on the outside. X times y raised to 2 inside brackets. Then you raise y and then multiply.
That may work.
I guess this is where I'm getting confused. I thought the computer theory order of operations.
Very important.
Is that correct?
Correct.
It does know the order of operations, but if there's no parentheses, it gets confused.
Okay.
Yeah,
Okay.
it's, it follows order of operations to a point, but it also reads it logically left to right.
Okay. Okay. That makes sense. I guess that's good.
So you're saying x
Yeah. So.
times y squared is divided by 12. So that this is multiplying by the result of this and then divided by 12.
It would do this first, and then
Okay.
So I mean, yeah, I guess that's the question. We want to rewrite the equation to do that the way, write out the steps for the different form, which do we want to do?
This would be less data entry, and ultimately, as long as the software read this properly, would be more efficient.
Okay. I'm sorry, 14 minus 4. That's what the group likes. I'm doing.
Now, this one, we know that 3 plus 4 is happening here.
Okay, I'm gonna set the alarm for more time.
yeah, but this way it would end up doing that first. Wait, this is the this is-
Yeah, this is part B.
Everybody good?
but each of these are just- Yeah.
Yes, but they're all inside this original opening parenthesis. So it's going to do, the way it's written, it's going to try and do all of this.
Yeah, if you want to write it out like that.
Where
probably
we want to make sure that it's processing this and this, so that those are there, then proceeding through.
I don't think we have to.
That first, and then you can kind of go down the flow chart from there and say, what is the,
Do you hear that weird beeping?
yeah, it's a computer that's having a problem.
Oh, okay.
It's not.
I thought we were gonna blow.
Yeah, I took
Do we have to write one separate ones?
I think so. Yeah, we'll have like a A and B.
So now we have however you.
I mean, we're still writing this as a first one.
This is the highest.
I think you can either write it as pseudocode or just steps.
Okay.
Was the next one?
Well, and then it's not saying it's so coordinated.
Next, time. And, that's fine. That's highest, therefore.
Yeah, I think you're right. I don't think we've got to do a lot of rewriting to that. I think that's probably going to process part of that, but this one,
Yeah, two parentheses, X plus Y.
we had to put this into a parenthesis. So if we rewrite a, you know, basically we're just entering it in. This is 3, Y is 4, and then write this way for A.
Then that's only one operator.
Those same variables could be used for B. And we just write E like it is. It should process. I tried to do it the way it should have. It seems to be working right. My math could be wrong too.
Okay. So before I start writing, or somebody else starts writing something. So if we declare our variables, we have to say X is an int, Y is an int. And then we have like solution B and solution A, would that be the other variables and those are
Yeah.
too? So that's probably the highlight of solution. Steal some more.
Sure. And there's more. I'll get another package out.
That's right. So that's
That's the last one. Just take the whole thing.
Yeah.
Something to write on.
Like actual paper.
Oh.
It'll peel off.
And then we're basically going to set X and Y equal to the value, right? At that point.
Yeah.
So then we just say
X is 3, Y is 4.
And then we go.
4, and then set solution A equal to this. Right.
So
It
it's
would
X,
be
X times, which would be asterisk,
times
parenthesis, Y caret 2 Divided by 12.
So does that look right for setting solution A?
Yes.
Can we just write that out the way that it's already written?
Yeah. Subbing an asterisk here and caret for the.
Oh, I have not.
Close parentheses. That would be asterisk 4.
Asterisk 4, close parentheses, caret 2.
Yeah.
Right?
Yes.
And then, once that solves that, we want to actually write out the solutions.
Yeah.
Correct?
Yeah. Which this would be 3 times 16, which is 48 divided by 12, which would be 4. And this one should be 254 if my math's right.
Okay.
If somebody wants to double check my math, go for it.
I trust you. I just feel useless. Are we breaking these up into modules? Like,
Oh, my calculator says it ends up being 100.
Okay.
I think you left off that 4. It's times 4 raised to 2.
It's right there.
She said basically there's one
Wait, calculated. It says it's 100.
This, how would the user know what problems we're solving?
We, I think for this, we would probably write the expression properly. And then the solution. So in this case, it would be
You guys want to all sit down real
So instead of saying expression, we write out this,
yeah,
right?
yeah.
fast?
We would declare this as expression A and this as expression B.
Yeah, because that's what it is. Expression A, expression B.
Well, everybody go in one area because I can't get you all. So if you all like to bunch up. This side you want, this side? Yeah. Come over here to this side. With the octopus in the background, yeah. That's awesome. So I'm gonna stand on this desk. If I fall, then I'm gonna like sue OTC. That's all right.
I'm short, so being in the back will be good.
No, man, this is awesome. All right, you guys have to bunch together. Okay, this isn't a wide angle thing. Guys, you have like this area.
Okay.
Let me do that. This area. Let me do that again. Let's see. Now, some of you are still out. You have to pick. Go ahead, in here. Kneel down over here in front of him. Just to be famous. Come. I'll give you extra. If anybody's objecting to being in this video, step out. I understand. Please understand that this is This is not gonna go outside of our department. This is us showing everybody else in the department what we do to you guys, right? So if you want to emote, now's the time to say how many of your teachers are, and I'll record it in your bad voice, all right? So my hope is that, what do you guys do? You tell me, what are you doing in this class? Do say something good, because she's listening. What are you doing? Huh? What did you say?
Software piracy?
I wish I recorded that. So what do you guys do in this class?
Absolutely
nothing.
Now they go quiet. They had a lot to say a second ago.
Yeah.
Now they're rolling. What do you guys do? What are you doing right now?
Programming.
Which means what? What are you doing? What is your program?
We're writing code, pseudocode, soon to be Python, interesting stuff.
And we're learning the logic behind computers that can be applied to programs.
Do that again. I missed your face. What are you doing here?
We're learning the logic behind computers that can apply in programs.
Fantastic. All right. Anybody else want to add to what you're doing here?
It's fun.
Do it again.
It's fun.
Bonus points for you. All right. So what I'm going to ask you to do then is, like, all together, let's come up with one phrase. What are you doing here? You guys, what is one phrase you can all yell at the top of your lungs with the most amount of excitement and glee you can possibly think of? Liar. The part that's fun.
Typing.
You do typing. What else?
Carpal tunnel, that doesn't.
I mean, really, it's up to the teacher for what she wants us to do.
We do problem solving so we can write awesome code. How's that?
Yeah.
Okay, gotta do it slow so I can pan, like we do, so I can, since you guys all refuse to be squished together, I have to pan. I have to stand back. This will be entertaining. Okay. All right. So what's the word? What are you guys gonna say?
Problem solving,
Problem solving.
so that we can code.
I see your point about this class. Now I understand. We do problem solving so we can write cool code.
Okay.
Do it again. Let's do practice. What do you guys do?
We do problem solving, right? I haven't had my coffee.
All right. Take 8. What do you guys do in this class?
Problem solving so we can write cool code.
Awesome. I appreciate that. Thank you. Thank you.
Should have brought a program to solve that problem.
Right.
I appreciate that.
We need a flowchart to accomplish that.
Here's the contest. I'm going to have my classmate next door. If they are louder than you guys, you're all going to fail the class.
Okay.
Just letting you
All right.
Yeah, but I have some of you in another class. Thank you for letting me know. Thank you.
Okay, so we're gonna write this on the thing, or are we just
Yeah.
I'm ready to see.
Are we gonna write it as a virtual program? Because then you would put in what problem you want to solve, and then enter X. We could just do it as normal program and use those problems.
Okay, start on your
Yeah.
side.
We can just input those problems and then what X and Y is.
Do you have the marker? You should do the marker.
I can't write it.
So start on the next one. Signers.
I always see my handwriting.
So, okay, that's right. I know you. Okay, so I don't know.
Yeah, I'll get you.
Okay, tell me what to write first. Tell me what to write first.
Declare X and Y.
And he's got that already, you could paste that on there, but you might have to make it font.
Okay. So say
X if you get done, start on the it's an integer because there's no decimal.
It's an
okay, so set X as integer. Okay. And set Y.
Hide back here.
Air purifier.
Huh?
Air purifier.
Trying to stay alive in this deadly building.
You gotta do what you can.
Whoop. I guess that's pretty dramatic measures for them to have in class. I hope we don't have to leave. I have a feeling we're to move to graph, and that's kind of
Yeah.
to it, and you guys would, but I would have liked you guys
Monday,
to.
Wednesday, that's where I'm at all day long. It's, if I want to get a parking spot that I'm not walking a quarter of a mile, I gotta get there.
Right.
All the networking centers are over there. And then some of the.
Well, and I think a lot of people just park there because it's the first one they see.
Because as of right now,
Well, it's also, we're running the PC repair clinic out there. So we have all the public coming in as well. So you'll have random people just come in and take a spot that a student would have taken because they're going to have their computer fixed.
And they were trying yesterday, the disability support group came in and he was, you could see he was going through in his mind and he said, we can't go, you know, over to IC because of the cafeteria and stuff.
Yeah.
And
So you're saying you want to actually have
I don't think there's any. I just don't know. I told him, I said, put me in a moldy room where someone else can't handle because no one doesn't bother me.
Yeah.
You know, just get me away from all these scientists.
The stuff over at Draft Hall, I think the worst you're going to deal with is they do have one vending machine that has those pre-jarred coffees.
Oh, yeah.
But
compared to what they're doing here,
yeah,
they're simmering. So that pink stuff that's in those experiments, the microbiology class, he does almost 150 of those things per week. And every one of them, he simmers agar stuff.
Yeah.
And sometimes it's just that, sometimes it's not stuff that would be dangerous to me. But like last week on Monday, it was simmered with gelatin and data, and I mean like 5 really heavy ingredients. And then Tuesday it was simmered with beef extract. And by Tuesday afternoon I had to cancel all my appointments. I was so sick. I had to go to bed and use the whole rest of the day Tuesday. And I can't keep doing that. The guy was cooking. He was making all of these things at night last semester. And he moved and started doing them during the day again this semester. So that's why last semester wasn't a problem. I thought, I got this beat. I'm not having trouble. It was just totally outside of my control. So now I just, my whole basis for decision making is screwed up because I might be able to eat things that I haven't been eating because I've been sick because of the building and because of stuff that I've eaten that should have been okay, you know.
Yeah.
It's crazy.
Graph is also pre-filtered.
Is it?
Yeah, all of the servers are hosted over there.
Well, I wonder what's wrong with the building because, you know, in all their plans, it's gone. So there's something wrong with it. Do you think it's just like foundation issues? I think it might be just that it's foundation issues. Yeah. It's where I went to Votech.
Yeah. I think it was built in
1960 something, 69 or whatever that tech, the Votech.
49, I think, is when it was built. It's a fallout shelter.
Oh.
The basement functions as a fallout shelter.
Well, I think it would be an okay one. It feels real dry in there because of all the computers. But other than that, it's
I'm
not a deadly
positive,
building.
But I'm about 80% sure that is a former military building. Because when we had all the U.S. Army medical staff here in the 40s and early 50s, we owned all of
That's what a lot of those
Drury's
buildings
campus,
are.
Evangel's campus was all military.
That makes sense. Because buildings are trucks and stuff.
I think that was an administrative building for medical.
Cool. Well, that's really, it's been around. All right, we got some beautiful solutions here. We're stopping. Okay, let's go over here. Let's go back here because they got done first.
Okay.
Okay, back to you. Can you guys stick your solution up there where everybody can see it and tell us a little bit about it? And we're just going to stay up and look at your giant post-it notes and see what you have to say.
This, well, like, don't go for this, you know.
Okay, so tell us what's going on here.
You know, that there's assignment statements.
I did.
So for the first one, well, they said we went from the X equals 3 and like the 4. So we just plugged in the 3 where the X is and the 4 where the Y is. And so first you would do 4 squared because your X is first. So you have 13, 16, 5 by 12. Then you just go in order with your multiplication. So 48, 5 by 12, and 9 equals 4.
And the second one, you would do everything inside the bracket first. So for everything, we have brackets inside the out brackets. For 7, 1, and then do multiplications.
Looks good. All right, let's go over here. No. Okay, you guys are.
We're still trying to figure out how exactly
That second one works. That's fine, because I want you to leave them up after you're done. What about you guys? You're still
We're building our
building a solution here, a problem solving, mathematical solving. Good. Okay, and over here. Oh, let's see what that is.
All right, so you basically set all X to 3, and you set all Y to 4, and then you follow PEMDAS. So 3 times 4, where you do 4 to the power 2, which is 16, and then 3 times 16 is 48, and then divided by 12 and 4. And then same thing right here, you do everything inside the parentheses first, so you get 7 and 1, and then you get 7 times 2 and 1 times 4, which is 14 minus 4, and then do that, and you get 10, and 10 to the power 2 is fine.
And what's PEMDAS?
Please excuse my trying to see the exponents.
And what's the memory aid?
Please excuse my generous.
Because you know that hasn't been in school for very long.
No.
Not very long. So everybody's like, PEMDAS. What?
It's a chain after I was out.
Yeah, it hasn't been around for very long. Some of us don't know what that means. Now we do though, because you guys explained it. All right, what about up here?
So we just had declare variables, set X as an integer, set Y as an integer, and then input problem A, and then I forgot to write problem B there, so just pretend problem B is right there. So input those two problems, set the X's to 3s, set the Y's to 4s, and then have it write expression A is plus the solution, and then write expression B is plus the solution.
Good. Okay, so lots of different ideas, and here they're finishing up. What have you guys got over there? Right.
Well, we set every X equals 3 and then Y equals 4. We write out the problem by plugging in for each variable. Use PEMDAS for the group. And
It's really good. I have a couple of questions for all of you though, because great job. You're all approaching from, you know, several different angles, and that's fine. That's what we want to see together as a class. But a couple of things for us to think about. When we take that 3 and we replace all of the places that were in X with that 3, what's that process called? You could say it's an assignment, but when we're doing sort of a desk check like this, when we're walkthroughing, we would call that variable substitution, right? Because we're substituting this value for all of those variables in that formula so that we can then solve that formula. So that would be the big word for what we're doing there when we do that kind of thing. It's variable substitution to get that value in where that variable is. And in our program code, we would use an assignment statement to make that happen. But when we're desk checking or walking through on our own, sometimes we have to do it ourselves, like we find out our answers. Okay, come get another piece of paper and let's do a flow chart. Sum of 2 numbers. Sum of 2 numbers. Grab another one and work with your group and let's make sum of 2 numbers. And I'm only going to give you like 10 minutes. That last one took too long, so 10 minutes. Yes, the first one. Sum of 2 numbers. Flow chart. Just stick this one on top of your math one. Isn't that Travis? Just a flow chart. I want you to do the pseudocode on the side, but I don't. The main thing is having your flow chart on a big sheet. I'll get some shapes up here.
Number 1, square, number 2.
Yes, we basically just need 2 number variables. We have to have 2 variables.
And then 3, sum.
All right, we're gonna merge still. Where to go?
And then you would have an output.
We have to enter 1 3.
No, we're doing just the top 4 lines.
Yeah, it's basically
A lot of people are.
So number 1.
Interesting, isn't it? You can kind of do it. I know.
But it just means 2 at the end, correct?
Right, you will have to. You can pick up to 2.
At the end, at the beginning, you can only pick 1.
1 to decide what your second is going to be. Yeah.
That way it's there, like it looks around. And then you have a sum, which would equal 0. And then you would have an input system, input number 1.
Yeah.
Input number 2.
And that's what
And then outputs the sum.
So we need to set a module for input. We need a prompt for X and prompt for Y. Set those.
This is all going to be inside this main.
correct. Yeah.
So
So the next one would be called the input module.
no,
No.
it's all
It's all
the
the same. We're not calling it.
So our next step would be an input. So we would draw the arrow to the next box. We would have the arrow going into that box. And then input or prompt for number 1. And then you would,
Do I start the next row?
yeah,
Yeah,
and
you might
make
have
it,
to make like a line or you can just go.
yeah.
That'll work.
Yeah.
And then this would be just an output statement.
Well, then we gotta do the sum though.
Well, the sum will be set equal to,
It's gonna be input 1 plus input 2. right?
Okay, erase where the 0 is, so it should be equal to 1 and 2.
Well, I thought we were just saying.
Then this was just setting as like integers.
Yeah.
So then sum is equal to 1 and 2.
Yeah.
I mean,
Okay.
either way.
Second equation. Oh,
Number 1 plus.
Are you doing it right now? Okay. So we're getting over here. And we can decide on the shapes. I think that's the.
In reality, you know, you'd probably say the sum of number 1 and number 2 is, yeah. We just don't have that much space.
Like this.
Nice.
That's.
You guys better start on the fruit one then. Grab another piece of paper. We'll have paper all over this room. Be a fire hazard.
Where was the problem we were supposed to be solving earlier? Because we're still trying to do that.
Oh, okay. Let me print that for
Would you
you.
like a picture of it?
That's what I was going to say. I can print it. They give me all these helpful little pop-ups and then I can't do anything.
Some here. Represent, I'll get it back to you.
I'll print it for you. Thanks.
Yeah.
It's taking forever.
He digs through my phone and sees something he doesn't want to see. That's
Exactly. We all take a risk. I don't know if it's actually going to print. Hang on.
that printer's on.
See, I'm going to go to this one. I forgot.
Can we get some else though?
Sure, you can.
I can't see it.
And I can print these too if you want me to.
Yeah.
You just commit to sign. That might be nice of me. We're in this, you know, paper-free environment, make you guys suffer.
Oh, okay, well, that works good.
I think that's enough.
Do you want the fruit one to be Pseudocode or flowchart?
So chart. Since we have our big sheets, let's do our visual. It's gonna print eventually.
We can't use user selection.
You're gonna have to use a statement in this one.
Okay, perfect.
Otherwise, you won't be able to tell what kind of fruit they got.
Yeah.
It can't go the other way, can it?
She's no, you can't.
Do I?
It's like we can pick bananas first. But that's great.
Let's see where I printed it.
It can be an orange or a banana.
There it is.
So there's only 2 great solutions. Is that what that's saying?
Yeah.
And
Apple plus banana is
Super
correct. Orange plus grape is correct. Grape plus banana is correct.
It says 1 input box, 3 decision boxes, and 4 output boxes.
Okay. So then are we doing declaration stuff? There's not really anything to declare.
could you grab me one for fruits or something? I'm very confident in these or something.
I see.
I don't think we have to declare anything. We just have to.
Because they're declaring it as strings anyway, and that seems like kind of a waste of time.
And in Raptor, you don't have to declare stuff. But we just have to input 1 and then read it.
No, they're fine. Okay. Okay, this is where it's, working on for a long time, he was much great videos. That's pretty close. Okay, yeah, we're supposed to screen. Cool. So, okay, let's go to.
Get like beside this. So it's you're in the apple. If apple go this way and have probably you have an apple and the banana.
Okay, so that timer was for our sum of two numbers. Is everybody pretty much done with that flow chart? Everybody put your sum of two numbers flow chart on the top or wherever you have it, and just kind of look around at everybody's and see if you notice anything that looks really, really different than yours that you want to check out. I like it. I think they're looking good. Okay, I think most everybody is working on this Scrooge problem now. And I'm going to set my alarm for about 10 minutes for it.
And on the fruit one, are we doing a flow chart?
Just a flow chart. Thank you. Just a flow chart.
So we don't have to write out a flow chart in Raptor, or we're writing a flow chart on our paper?
Just on your paper. Thank you, Isaiah. Yeah, we're just going to stick with our paper today.
So I guess I just gave two declarations, right?
No, let's see.
Yeah. That's what we were supposed to create.
It says 3 decision boxes and 4 output boxes.
So.
I don't know. Yeah, but if you answer no on everything, eventually it will just be you have the apple and that's it.
So that would be your fourth.
Are you taking networking classes over there? Are you taking networking classes?
Yeah, dual major.
That's so smart.
Starting with
I've been in IT for 20 years,
Uh-huh.
but I haven't had the
You can only start
degree
with
saying, you know,
Yeah.
work for Apple, I work for Hewlett
Uh-huh.
Packard. I've had these high-profile positions, but that degree, you know, it's making it hard for me to get the salary that
Right.
I should
Because a
have.
lot of times they'll give you the responsibility.
Yeah.
And the authority, they just won't give you the pay.
That's exactly the problem.
It's frustrating.
I was supposed to draw a Raptor a solution to the second problem.
Just draw it.
Okay.
Yeah.
Drawing.
You got grab another piece of paper and double
Problem
it.
I had was last year, I got passed up for a promotion at my last job where the pay increase was going to be about 45 to 50,000 a year.
Uh-huh.
I didn't get it despite 20 years experience. They gave it to somebody with 2 years experience because he had a degree. They said HR thinks that he's better suited because he has a
Right.
degree.
And I have two former students that come in. They've done wonderful about coming in and being guest speakers for C#2, and it's really cool because they both work at Jack Henry, and so they'll come in together and they kind of play off each other. So it's a lot better than just one person standing up there talking to the class. So I really appreciate it. Sure, you are set. And this last time they were in, they sort of graduated together. One of them got the job at Jack Henry before the other, and so he kind of got that other guy on. So, you know, but they started pretty close to each other. Their backgrounds are pretty similar. The last time they were here, the one who just got promoted, and he's now the other guy's supervisor. And I said, so you have a
should just be get out,
Yeah.
put in. Cause
Yeah.
Yeah. Previous.
Yep.
meals. So I think that's why you want that.
a banana, that's all you have. And because you wouldn't gain anything else.
You actually only.
Is it bad? What does it say?
What
do you think?
Let's see what we got. She was talking about.
No, you're good.
I'd say, yeah, that's solid.
Because I almost think it has to be a loop to come back up here to say you didn't enter one of those three. So that was come back and try to figure out.
Yeah.
You basically have to enter one of those three.
I would say make that a loop.
There's like rules.
Yeah, no, yeah.
Well, I don't read this as a rule so much as a guideline. We know there's going to be a single input box and 3 decision boxes, 4 output boxes. We've got that.
This should be the output box.
Yeah.
Guys, I grabbed that one off the internet, so ignore that hint.
Invalid
Do what
entry.
you think.
Might be easier.
That hint seems flawed.
Okay, yeah, just have it stop.
Yeah. Yeah, just invalid entry.
Okay.
What you get? Right, stuff up here.
You know, because if somebody decides they're going to be cute and put in kiwi fruit, well,
So if you needed a ride to class, would you want to go to a ride share channel in Discord or a carpool channel in Discord?
I think rideshare.
Ride share sounds more relevant. That's what I was thinking, but I was like, okay.
Carpool is an antiquated concept.
Yeah.
Only
And it
older
implies
students-
a permanent
Yeah.
sort of thing.
Whereas, you know, rideshare, I think it makes sense to everyone.
I think we need that because so many times people are just like out of gas or have something wrong with their car when
Yeah.
probably somebody else is just going to drive right by their house.
Well, you know, it's like I'm driving from Republic. At any point, somebody, you know, I'll be 2 or 3 minutes late potentially just because of traffic. But if somebody needs a ride, I'll stop.
And that's
pick
a
them
lot of
up.
distance that you're covering,
Yeah.
you know, that you could pick
That is
somebody
a
up.
large, you know, I'm driving in from Republic, so, you know, there's 15, 16 miles of distance right
Just have trouble with cars and it ends up messing up their classes and stuff.
Well, you know, and then on top of that, you'll just have the people that are, well, I don't want to gas. You know, I don't want to go to security and ask for a gas card.
So how do you? Because I mean, if we got a ride out of
And the yes in this one's going to be great. They would, yeah, but how much is going to be? Yeah. Yes. And this one's going to be.
So, I'm assuming since we're up here.
Yes, we'll do bananas. One peeled banana.
Open banana.
Okay.
Do you want us to, like, this one, like at least 3? I don't either, because that doesn't make sense. Okay.
Well, we're gonna look back up and yeah, basically, if you don't take one of those fights, it's gonna stop.
Yeah, that
I
makes
just
sense.
have no idea if they wanted some.
So do we want to
Get it off my Word document. Just driving you guys crazy.
In your input statement, you know,
Unless it's like there's
when you're
three
writing,
statements.
you can say
I think
enter apple, banana, orange, grapes, whatever.
And like you guys, everybody's for 4. Because we're not programming overseas, I guess. Maybe we would know what that 4th box was. Okay, what is that? Oh, nice. Okay. Do all of those? Do what?
Dairy and fruit. Stinks.
Oh, yeah. How's everybody doing? It's too fruity.
Good job, team two.
Yeah.
Okay. We've got a few that are done.
How'd you guys figure out the decision? Are you just winging it? Or
Are you confused about the report
The decision. Yeah, it's based on the decision. It'll test the variable and then.
So it would say
yes.
fruit.
that I understand.
They input fruit, so it should say fruit equal apples or fruit
Yeah.
equal
Just input.
orange. Fruit. The way you have it, you could say if fruit equal your apples variable. It's already there. Let's take a look at some of them. You're out of time. What does that mean if you're out of time? What if you didn't get done? Well, we're not grading, so you're not going to fail. But it's a common thing that happens to us as programmers. So the first thing to ask yourself is, if your group ran out of time, part of it is probably confusion, right? That's a normal thing. But what about scope? What does scope mean? What do I mean by scope? I mean limiting yourself to solving the problem at hand, right? Don't create additional problems for yourself to solve. And it's a really big deal with us beginning programmers that we tend to do that. We want to make sure we don't leave anything out. We want to make sure we do it exactly right. So sometimes we tend to really overcomplicate things. So there's this old acronym, and it's still sometimes used, KISS. And it used to be keep it simple, stupid, but then I guess they decided that wasn't very politically correct because it seemed cultural stupid. So then it turned into like keep it simple, sucker or something.
Simple, silly.
Keep it simple, silly. Basically, keep it simple. Don't be adding extra stuff in on yourself. So if I'm going to make some cookies at home, and I decide that I need all of these ingredients to make these cookies, and I go to the store and I get them and I'm all ready and I'm making these cookies, and then all of a sudden, while I'm cooking, I get this wild hair and I'm like, boy, you know, I would really like some spaghetti and meatballs to go with these cookies. I have just blown my scope way out of proportion, right? I didn't get those ingredients. I don't have time to make spaghetti and meatballs. That's what happens in here. So we want to make sure that we're super focused in on the problem at hand, because we want to get it done. We have a limited amount of time, and it's really great to get excited and think about other problems to solve, but those kinds of things have to go outside of class because we have such a limited amount of time. So I know there were a couple of issues with scope. A lot of you were just totally working on the problem at hand. We have a lot of people, and we didn't have very much time. So there's a little bit of both. Let's jump over here and look at this flow chart, and I want everybody to take a look at it. And will you guys tell us a little bit about it? It's a nice, simple solution to the fruit thing.
So we just had the one input box, which was input whatever fruit that you picked first. And then we just had decision, diamonds, and then yes or no, depending on what the choice was. And if it was yes, then your output was the definitive, like if you put in an apple, you get a banana. And then if you didn't, then it went down and gave you your other options. When it eventually came down to this fourth output box, because we were kind of confused as to why it asked for four. We just put this invalid entry because, like, let's say somebody tried to, like you said, put in kiwis or whatever just for fun, and then it wouldn't accept that. So we let that fourth box stay there just in case somebody had a wild hair and put in something that they weren't supposed to put in.
Great. And notice how when we're using these design documents, things can be a little bit more flexible than when we're actually doing program code. So in their flowchart, there are a few little details that would keep us from being able to just put that directly into Raptor, right? It's missing a few pieces, but it does a great job at conveying the logic that we would need to be able to solve that problem. So again, it can be kind of confusing for us because whenever we're working with design, we might just be conveying the logic. You know, we might not get down into the details as much as we will in our program code, but sometimes we might get down into those details. It totally depends, again, on the problem we were given. You know, we have to be aware of that. Let's go back here. What have you guys got?
Which one?
Sure, you guys show us, and then we'll jump to the payback.
Well, our start thing, we initialize both of our variables, and we ask the user to input a fruit. We then go to our decision diamond, which instead of splitting it into three like they did, we just decided to make it radial and have a bunch of options coming out. If you pick either grape or apple, those both converge on the same outcome. The second fruit must be a banana. If you picked orange, then it goes that the second fruit must be a grape. Else, there's a little other option here that brings you back to the beginning so that you can pick again if you pick a kiwi. There's an arrow here too that's not necessarily coming out of an edge, but all of those things eventually will lead to outputting the two things and then end. And that's that.
And it accomplishes it. Now with that one, we're being general and we're getting that information out there. And as we look at it, the decision diamond can only have 2 lines coming out of it. That's a rule, right? So that's a rule. Okay, let's go back to the back. It's almost say. It's an important rule.
Well, yeah. Same here.
Yeah.
After we started, fruit, big one,
Well, sometimes, I mean, I say that it can only have 2 lines. In some cases, we could refer to it as a case statement. So this sort of implementation would be something that we might see. So in CIS, we always have flexibility with our rules. So if you can see there, he just has it up at the top, one decision, and then underneath that, he has like the first box to say if they pick the apple, if they get whatever. So that's a great way. This is a great way. We just want to remember some of those requirements that we have. All right, what about over here? What have you guys got? Okay, that's all right. And you guys were working on it. That's all right. That's great. I wanted to give you plenty to do. Now, for your unit exam, if you want to go ahead and go back to your seats and let's take a look before we get out of here. Sometimes I get so excited about you guys learning stuff that it's too exciting.
That's it.
So I'm going to look at this practice exam. Remember, this is in Canvas in our modules under the week 4 stuff. I'm just going to preview it and let you kind of see what we're going to have with it. Now, again, the practice exam is the same test bank as your actual exam. So you can see question 1 just asks a nice multiple choice question. Question 2 does a little bit of a calculation with that variable substitution like we were doing earlier today. What would the answer be to that one? Can you see it okay? Hard to see. Well, we set it to 30 here. Would this next line of code change that then?
No, it says, it's coming out of the declaration 30, and we're multiplying hours by 6.
So still 30. Mean, huh?
So would both of those answers be correct? Like if the guy that goes on the test, like would they both count for answers, or would it just one?
Just wants 30. And I think that they, in the question bank, they do it that way because then it kind of confuses you a little bit because you think, oh, it can't be 30 because that's what they set it to in this statement, but then the calculation comes out to that same amount. Pardon? No. You can if you want, but we're out of time. I just wanted to show you. Now, this exam, after you're done with it, I can totally tell who did the practice exam and who didn't. Because doing the practice exam is that important. Because our textbook gave us this question bank, and they have a really interesting way of asking some questions. So it's just really important for you to go through the practice test to get an idea and understanding of how they like to do that. After you've done that, even just one time, you'll be so much more prepared for the exam than anything else you can do, because you guys have the knowledge. You proved it today. You know how to do the math problems. You know how to do a flow chart. You know how to interpret pseudocode. You're in really good shape for this exam. Now you've just got to get used to how the textbook asks the questions so that it doesn't throw you. Any questions?
Question 3 is equal with that 8 being on the 3rd line.
Mm-hmm.
When you budgeted, let's say it. So we should install Raptor on our computers to finish this assignment. Has one Raptor flowchart.
At the very end, you know what? I think I'll delete that question. I'm glad you asked because I don't want you to have to install Raptor at home. Yeah. What do you guys want? I mean, I don't want it to be a problem for anybody.
I won't be able to run Raptor.
You won't be able to. Yeah, I'll just delete that question. And it's pretty close to the flow chart that you have as your unit exam hands-on anyway. So thank you, Isaiah. I really think that that could cause people some trouble. I like to get rid of those problems before they happen. Any other things that can prevent troubles?
So like, let's say there's a question on there, can I write that in my chapter 1 notes? You know, that's like, it reminds me of something.
No, not the question. So you could make some notes about it, you know, like something that you wanted to remember. The concept, but not the actual question. Mm-hmm. So important. Don't forget about those notes, your study group, and you can share those notes that you have. Have a great day. Thanks, you guys. We'll see you next time. Next Tuesday. Don't forget your test.
Open note, not open book.
Right. Open note. No Thursday class. So just take your quiz. Yes. Next Tuesday. Well, no, wait. Next Tuesday is that day off. Isn't it?
Yeah. The
So,
college.
not till next Thursday. Oh my goodness. I did not realize I won't see you for a long time. Thank you, Josh. We'll figure all those interesting things out.
Notes on these.
Okay.
Are we allowed to use scratch paper?
Sure. Actually, it's very helpful.
To write everything out.
Me too. Me too. It's important. I love the way you think. You are you're such a high level thinker.
I think I
I
went too
love
high.
it. I need you to. You
I
do
went way too high. Like, we almost didn't get that assignment completed because we actually went for a pseudocode implementation of what you were asking, instead of just writing out the solution, which is what literally everyone else did.
You were getting work done. That's the main thing. You know, it's,
Hopefully.
yeah,
I feel like we did a very good job.
making him think about things and stuff like that. It's important. There's not always a right answer.